Hi all, we present to you the introduction to our project Robo Goalkeeper for the microcontroller course. We are all familiar with the world famous sport soccer and the role of a goalie. Keeping this in mind, our first step of our project is breaking it in chunks. First being identifying the objective and associated functions which is depicted in the block diagram.
Keeping our objective in mind, which is to block the ball as it approaches the goal post, our block diagram depicts the following. Here we are using an ultrasonic sensor to sense the ball and estimate its coordinates. This sensor is interfaced with the microcontroller Arduino Uno, which will be programmed to instruct the servo motor to move accordingly. The servo motor will have a wood or hard cardboard goalie mounted on it, which will emulate the function of a goalie. The power supply is provided for the microcontroller and the servo motor.
Identifying the components and selection of the apt ones to suit our need is the major chunk of our project. Ultrasonic Ranging Module HCSR04 provides 2 cm to 400 cm non-contact measurement function. It comes complete with a transmitter and a receiver module. A few features of the ultrasonic sensor here being the ranging distance being 2 cm to 400 cm, the measuring angle being 30 degrees. The ultrasonic sensor has the following 4 pins: VCC, trigger, echo and ground. They are to be interfaced with the Arduino Uno board. The VCC to the 5V pin of the Arduino board, trigger to the first PWM pin, echo to the second and ground to ground.
The next component of the circuit is a servo motor, which is an electric motor that works on servo mechanism. Under servo mechanism, an automatic device uses error sensing negative feedback to correct the performance of a mechanism. It will rotate the motor to a given angle based on input signal. Now, the reason why we are using a servo motor over a DC motor is that it provides angular precision. It will only rotate as much as we want and then stop and wait for the next signal to come. Unlike a normal DC motor, which starts rotating when power is applied to it and moves on until the power is switched off. Now the interfacing servo motor with Arduino Uno. The red wire is the power supply which is connected to the 5V power supply of Arduino Uno. The black wire is the ground which is connected to the ground of Arduino board, and the yellow wire or any other colored wire according to the servo motor is connected to the signal that comes from PWM pin 9.
Having explained the major components, we move on to illustrate the end design of our project that we've envisioned. The goalpost dimension, 14-inch goalpost when measured diagonally. The ultrasonic sensors are placed on the 4 corners of the goalposts. The ball is sensed and the microcontroller directs the motor, which has our goalie mounted on it, to move and hence blocks the ball.
When do we expect it to work? The ideal case will be when the ball is in the center of the transmitted beam coming from the ultrasonic sensors placed at the 4 corners of the goal post. The ball is at a distance of 2 cm to 400 cm, which is the range of the ultrasonic sensor. The speed of the ball has to be within the sensor accuracy range, providing it enough time to assess the time of arrival of the ball. The motor should be properly synchronized with the microcontroller. Since the motor does not have a very large response time, if the sensor sends a distance to the microcontroller in time and the speed of the ball is in range, the robot will work as expected.
Now let us look at the cases when the project might not work. If the measuring angles of any of the 4 sensors will overlap, it would be difficult to calculate the exact position of the ball. If the speed of the ball is fast, the sensor speed and the microcontroller speed might limit the response time of the robot. The robot kicks in response in the presence of any obstacle irrespective of ball. The detection of round objects might be difficult because of large angular deflection and the and as the received echo might affect all the sensors other than the intended one. This sensor is a general purpose sensor and it has a large response time for individual measurement. It has poor angular measurement.
The division of work is as follows. Subhashri is going to deal with the working of sensors. Aks will be handling the working of algorithm. Soumya's contribution will be troubleshooting and finding the plausible solutions, and I will be working with the motor calibration and motor response.
Planning is the first step for the accomplishment of any task. So we have assessed and plotted the Gantt chart for our project. The entire project is divided into 4 modules to be completed. The first module is the C module. It's been divided into subtasks which include positioning, interfacing and calibrating the sensor and the sensor programming in the Arduino. The C module is expected to be completed by the mid of March, which is after the completion of Cat 1 exams. The next module is the See and Learn module, which is the sophomore phase and includes formulating the algorithm for the calculation of the distance and position of the arriving ball. We have assigned this module a period of about 2 weeks to reach the milestone before the commencement of Cat 2. The pre-final phase of this project is working on the ACT module, that is working with the motor and the response of the goalkeeper, and the final integration of the project. The testing and the debugging of the final project is expected to be completed by the end of April.
So here we've reached the end of our introductory video. Thank you for watching us. Adieu until we meet again.